In section 2, we talk about address resolution protocol. As we have mentioned before, each node on the network has both IP address and MAC address. The IP address is used to forward or to route information or data from one network to another, whereas the MAC address is used within the local area network to switch the frame to the particular destination. In order to send data from the source to a particular destination, the source needs to know the IP address of that destination. So imagine when you send a letter to a person, you must know the address of that person. However, sometimes the source does not know the physical address of the destination. So the source or any node on the local area network needs to learn the physical address of all the nodes on the local area network with the different IP addresses. That's the main function of address resolution protocol. Address resolution protocol has two basic functions. The first one is to resolve the IP version 4 addresses to MAC addresses. So the source needs to learn all the physical address that corresponds to the different IP addresses on the local area network. And the second thing is that it needs to maintain that in a lookup table that can be used later on. So to understand this concept, resolving the IP address into MAC addresses is done by each node, that each node will send a request, which is what we call ARP request. The source node will send a request, ARP request, to learn the MAC address that corresponds to a particular IP address. This ARP request is sent as broadcast to the entire local area network, and only the node that has the physical address that corresponds to this IP address will send a reply back to the source node to inform it that uh, I have this IP address and my physical address is this. So I will send back the physical address that corresponds to my IP address. Then in the near future, the source will then use this IP address and physical address to send to this particular node. The second part of this is just that each node will host what we call an ARP cache or ARP lookup table that it uses to store the information about each physical address that corresponds to a particular IP address. So if host A wants to send to host C, for example, it knows the IP address of that machine. So host A wants to send data to IP address 10.10.0.3, but it does not have the physical address of that machine. Then it sends first an ARP request to all the nodes, and then only node C, because it has this particular IP address, will respond back. And when the source receives the response, it needs to update its cache with the fact that this IP address corresponds to this physical address. Then later on, node A will use this ARP cache entry to send a unicast frame to node C using both the IP address and the physical address. So that's the first case if node C exists on the same local area network as node A. If node A then wants to send to an IP address that has this IP address 176.10.10.50, something we notice here is that this IP address does not exist on one of these machines, or it does not exist on the LAN. In which case, host A will not send an ARP request requesting the physical address of that particular IP address. Node A will use some intelligence to know that this IP address does not exist on the LAN. And for that, we will talk about how Node A will figure out that this IP address does not exist on the LAN in the next chapter. But then node A will learn that this IP address does not exist on the LAN, in which case node A will have the IP address of the default gateway or this router port. So at least node A will have the IP address of that particular port on the router, because that port exists on the LAN. So instead of sending an ARP request to learn the physical address for that ultimate destination IP address, it will send an ARP request to learn the physical address of the default gateway port. So as we can see, the request will request the physical address for an IP address 10.10.0.254. So none of these nodes will respond back except the router. It will then send a response back to node A, telling it that I have this IP address and my physical address is 00107B E7FAEF. Okay, then node A will then update its own cache and then will use this physical address later on to send frames to the default gateway. Another characteristic of the ARP cache is the fact that if one of these nodes is removed from the LAN, I need to be able to recognize the situation and update my table. And this feature is done through a timer. So each node will maintain a timer for the ARP cache. If one of these nodes is down, then this means that this entry will not be used for some time. Then the node will wait for around like for example 2 minutes or something, and this time varies from one operating system to another. And if it does not use this entry for 2 minutes, then it removes this entry from the ARP cache. So each entry in the ARP cache is actually associated with a timer. So that's how the ARP table looks like on the router and on the host. And of course, these tables will be explained in details in the lab. One issue that exists for the address resolution protocol is actually the broadcast feature. So the ARP request is sent through broadcast to all nodes. And of course, that has the issue of overhead. So always the ARP request is sent with a significant overhead because it has to be sent through broadcast, which means that I have to flood the ARP request across all the nodes on the LAN. The other issue is the security. Well, for all types of broadcast frames, there is always the risk that some of these nodes will consume and will read the request and will learn something about the LAN. So one of the common security attacks is what we call the ARP spoofing or ARP poisoning, which means that one malicious node on the LAN will receive the ARP request and will try to send a MAC address by mistake to the source, and in which case the source will use a wrong physical address to send to the nodes, which means that the information will flow across the network in a wrong way. And that's one of the common security attacks that's facilitated by the fact that the ARP request is done using broadcast fashion. To fix that problem, in recent switches, they have two techniques to mitigate this. One technique is access list or authorized access list to make sure that whoever is sending ARP requests and ARP reply are actually authorized to do so. So it creates this access list to make sure that the ARP request and ARP replies are coming from an authorized node. The other thing is that it uses like some port security technique to filter based on these access lists. So if I receive an ARP request or ARP reply on one of these switch ports, and these replies are coming from an unauthorized computer, then I will not accept this ARP request or reply. So this way I can protect the nodes on the network from using any wrong physical address.